been asked to talk about the circuit. I guess the best I can do is point to the diagram and work through what's what here and there. So the plus and minus coming out of the 800 watt motor controller, that's a e-bike motor controller, 36 volt. Got a solar panel there that's what's that rated at? 250 watt panel. And we see about 31 volts down here, so if I'm at say 0.3 of an amp, or 0.03 of an amp, then we get what, about 1 watt, and it'll make gas at about 1 watt, which is significant because it didn't used to do that. So the plus and minus straight out of this e-bike controller come into here. The duty cycle of the e-bike controller is controlled by this, which would be the throttle on the e-bike. So what we've got is plus comes in here to this primary coil, and negative comes into here to this primary coil or choke. They're bifilar wound, so it's not drawn as the bifilar is, but you know, it's a bit more detailed to draw out the bifilar part, but for the sake of understanding and making it easy to look at, I've just drawn them as normal solenoid style. So the small ones in the middle there being the secondaries, which are the white stuff that's gone over the top. So they're joined together, and you can see that here by this connection shown on the circuit. So the energy collected into those when it collapses should shunt its way through and then superimpose itself back onto the voltage of the power travelling through to the cell. Now, the current draw is a function of how much power is being consumed in here, because the energy across these coils loads it up. So by that I mean, if I run it so that there's a short circuit between these coils, so the plus comes in here, hits that coil, comes around, hits the other coil, and then back, then you get a situation where the secondary coils alone with the diode are able to make gas, which I've never seen that before on a normal transformer. Except for another bifilar wound one, and that's why I've gone to this bifilar wind business. What else can I say? So the power, the actual conductivity of here governs how much current is pulled by these coils. So if this was like really conductive water, then it would pull more current. So it doesn't pull so much current because it is distilled or deionized water, which is what I always run in this tube. So yeah, I guess that's where we're at. Let's turn this thing back on and hit full beams, which is about 20 watts. Show you that. There's also this function where it seems to bounce. It's not a function, it's not a feature, it's a bug. So there's not enough current getting to this because that's a 250 watt and that's an 800 watt, and in a situation where it's not in full sun, it's not in a proper angle to the sun, so there's not full power, and the capacitors on here can't keep up, so they drop out. The power supply to this thing just carks it, and it goes in this cycle where it's trying to go full beans, but then it restarts and it creates like a changing gap. I'll show you what I mean. So we'll just go full beans. Wait, why is that not through? What's going on? Hello? Why is there nothing? Alright, disconnected that. But if we dial it back, it'll really pump the gas. That's at a point where there's enough current coming through. If I get more sun, I can take this up to about 0.8. Just gets me up into the 20 watt zone. So, yeah. So I guess, what else can we talk about? How I think this thing works? I think it gets a situation where when this collapses, the secondaries collapse as well and kick back, because there's a diode there and no diode on the other end. It forces it to push onto the power line, that's the DC that's choked. It feeds back on itself as well, because any power that's on these outer coils adds load to the core, which, like a magnetic amplifier, or what they call them, saturatable core controller circuits. Yeah, any clamping to this will reduce how much can go through here, which reduces how much gets to here. So it sort of feeds back on itself. Okay, that's it.